Welcome to my channel, guys. So today we are going to learn the clapeyrons three moment theorem. Three moment theorem. So basically, clapeyrons three moment theorem is we if we talk about the basics or simple concept of the three moment theorem, then it is first we consider the beam is continuous continuously continuous or continuous beam. We consider the beam is continuous. So the four type of the three moment theorem is basically analysis of the continuous beam with simple end support, fixed end supports, overhang and sinking of the supports. So before this simple support, the word come is analysis of the continuous beam. So the beam is continuous. In the continuous beam, we simple supports, then there is no moment. So moment is becomes zero. Moment is becomes zero. So if this continuous beam, and that's two supports, here is the support A, here is the support B, then MA is equals to 0, MB is equals to 0. So second, fixed supports, then fixed, this word remaining is end, fixed simple end supports and fixed end supports. So fixed end supports we denoted by fixed, this is the fixed end, we denoted this for the fixed supports. So there is A, B, then moment of A, there is a moment of A, there is a moment of B. We have to find the moment of A and moment of B. So our third basic is the if the beam is continuous, then there is middle something, this just this like this is beam of the simple support. So A, B and C, then MA is equals to 0, MB is equals to 0, but MC there is some movement, so we have to find is MC, movement at C. So this is the basics of the clapeyrons three moment theorem. And fourth is the if what remaining is MA, MB is MC is equals to 0, and no, there is nothing remaining, but I have to tell you that is basically simple supported beam, simply supported beam, there is simple support, then we take the moment equals to 0, and there is a fixed end supports, then with something moments occur generate. But here this is the reverse of it because of the beam is continuous. Basically if this is the beam and the beam is carrying uniformly distributed load, then something area of that moment is basically something area occurs by due to its bending moment is parabolic. So we consider the simple supports of carrying uniformly distributed load, then we analyze this is the A, this is a B. So if the beam is carrying uniformly distributed load, then maximum bending moments is bending moment max is equals to WL square divided by 8. This is the W meter, so kilonewton per meter, W kilonewton per meter. W means load, so W means load into length square divided by 8. So area, small a, area covered by bending moment is basically inside this bending moment diagram. So this is, here is the maximum bending moment is WL square divided by 8. So 2/3 of its length into, basically this is the maximum bending moment. So maximum bending moment is WL square divided by 8. So this is the basic formula of the area under the bending moment. And X is the center of gravity. So here is center of gravity in the middle. So here is the X divided by 2. X, center of gravity denoted by X, and it is the L by 2. So L is the length of the beam. Basically this is the length of the beam. So our second assumption is, our second is the beam carrying beam carrying point load at its center. So basically this is the L by 2, this is the L by 2, here is A, B, and this is the W at some point C of its middle. So here is the maximum bending moment max is equals to WL divided by 4. So this diagram occurs under the bending moment is basically the triangular. So here is the A, here is B, this is the length. So here is WL divided by 4. So area occurred by 1/2 because of this is a triangle, L into WL divided by 4. And the X, so center of gravity is again L by 2, means length, half of its length. So here is the half of its length, L by 2, L by 2. Center of gravity acts at its middle. So again our third case is the simple end supports carrying the eccentric load of W at its A. This is A, this is B, this is the whole length L. So here is A, B supports. So maximum bending moment max equals to WAB upon L. This is W, this is A into B divided by whole length. So area covered by the, so we generate the bending moment diagram just like this. So here is A, here is B. So in between, some here and here, something in between this diagram, center of gravity is acting. So this is the total length L. Area is the, again because of triangle, 1/2 into L into WAB upon L, and X is equals to A plus L upon 3 from LHS, and X is equal to B plus L upon 3 from RHS. If the low, if you're taking the bending moment about for this span AB, then we take it from LHS, and when we take for the BC, then it take from RHS. So this is basically for the two beams, for the continuous beam of the two parts. This is basically different center of gravity occurs. So different formulas are there for center of gravity denoted by X. So this clapeyrons theorem basically analysis by three different types. So analysis of continuous beam with simple end supports, with simple end supports. So simple end supports, analysis of the continuous beam with fixed end support. Third is the analysis of the continuous beam with overhang. And fourth is the analysis of the continuous beam with sinking of support. Sinking of support. Sinking means the support is sink by some few mm. Thank you guys.